Then we'd have plus or minus 2 divided by 2 is 1, so we just have I square root of 11, and it's all over 5. So the correct answer is A, negative 2 plus or minus I square root of 11 all over 5. Know how to do this. 4 minutes is way too long on this problem on the test. All right, it should take, I think that took me maybe a minute. And I talked through all of the steps. Make sure you can do that rapidly. Test on Thursday, quick reminder. We're probably not going to have test corrections just because it's so far removed. You'd have 2 weeks to do it. So the only way you'll be eligible for anything is if you fail the test. You're going to be able to retake a version of the test, but the highest grade you're going to be able to get is an 80. So I'll go back to what my syllabus said because it's just too hard to do test corrections on this test. All right, so make sure you study hard. Study hard for this one because there won't be test corrections. Also, it's going to be the first test on mark period 3. Don't start off weak on mark period 3. All right, that being said, any questions on what I did up here? Just the quadratic formula. Just a reminder, if I say find real and imaginary, you can't say it's just imaginary, no solutions. You do have to actually put your imaginary numbers. All right, if there's no questions on this, I'm going to hold off on homework questions until after the lesson because I want to push through as quickly as possible. It's a longer lesson, but it should go pretty quick. Once again, I'm assuming you know all this stuff. So if you don't know something, raise your hand and ask me questions on it. Otherwise, I'm just going to keep going. All right, the first thing we're going to start talking about is interval notation. It's a way to list a whole bunch of number solutions without having to list 0, 1, 2, 3, 4, 5, 6. In fact, it'd be 0.0001. So we have infinite solutions here. We either use square brackets or round brackets, which I usually call parentheses because they are parentheses. Square brackets, we use that when we want to include those values. So if we look here, 0, 22, that is all the numbers between 0 and 22, including 0 and including 20, because that's what a square bracket does. It includes. Our parentheses, on the other hand, do not include those values. So those would not be inclusive. So this 0 to 120, if it had rounded brackets from parentheses instead of the square ones, it would not include 0. It would not include 20. It would include that very first number bigger than 0, which is really, really, really small. But the only thing I don't include is that 0 and that 20. So interval notation, either use a square bracket or a round bracket. And the way we're going to know to use a rounded bracket or a square bracket is if we look at these examples really quick. So we have a whole bunch of sets here. And more particularly, these are all unbounded intervals. To be an unbounded interval, I need at least one infinity sign in that interval. And all of these, if you look over to the interval notation, they all have infinity in them. Now let's look real quick. So if we don't have an equal to sign, as they are here, we have x is greater than, x is less than a, we use rounded brackets or parentheses. If we do have an equal to sign like we do here and here, then we're going to use at least one square bracket. Now with unbounded intervals, infinity always is a rounded bracket or a parenthesis because you don't know where infinity ends. You can't include infinity because we've never counted up that high. Just know, equal to sign means you're going to use a square bracket. No equal to sign, we're going to use a rounded bracket. If you are just using rounded brackets, it is called an open set. We don't know specifically which value this is because it's got to be slightly bigger. So real quick here. If I had a parenthesis around this 0, we know it has to be bigger than 0, can't include 0. Can someone name the very first value that exists in this equation? Maybe I'll go to a blank slide. Someone tell me the first number that works for this interval. The lowest number that works for this interval. Yeah.
The 1.
Does 1 work for this one, though?
Yeah. No.
No, it doesn't. So what's the first number that's bigger than 1? You shouldn't be able to name it, right? It's just a point, infinite number of zeros, and then a 1. So you can't name where this actually starts, so it's an open. It's open. We don't know where it actually starts. You can't list that first number. That's why it's open. If I would change this to a square bracket. Now, Liam, what's the first number that works for this?
1.
1 works for it. So when we use that parenthesis, it's open because we don't actually know what value it is. We just know it's bigger than 1, and there's no way to list that number bigger than 1. But as soon as I use a bracket, we know it's 1. That's why the ones with brackets around them are closed, because we actually know what value starts them. And they're open if we just have parentheses, because I don't know what that actual value they start at. Let's go over some graphs. So if I say x is greater than a, you can write the interval notation a to infinity, because that's all the numbers bigger than a. Our graph of that guy would look something. I'm not looking for super great graphs on these guys. I'm just looking for something like this. We have an a value here. We're using parentheses because it is open. There's no equal to sign, so that's all I'm looking for. I'm just looking for that graph that's bigger than a. For less than a, it's going to look very, very similar, except we're going to go the opposite direction with our shading. We're going to make a point A. Our parenthesis this time will face the negative direction because I'm looking for those numbers less than a. So your parenthesis on your number line will face which direction you are going to go with your shading. For a to infinity, where a is surrounded by a bracket, this is a closed. So to close it in our drawing, we're just going to put a bracket there. We're just going to put a bracket on A, pointed in the up direction or a positive direction, and we'll shade in that direction. That also follows that if I'm looking for all those values less than A or equal to, we're going to put a bracket on A, and we're just going to go the opposite direction. Let's run through some examples, and it's not too hard to come up with examples. If I'm looking for x is bigger than a number, it could look something like x is bigger than 3. An example where x is smaller than a number, that would be x is smaller than, I don't know, 5. Doesn't matter what number we put there. Our example of greater than or equal to would be x is greater than or equal to 3. Or we could have x is less than or equal to 5. Doesn't matter what numbers we use here. The big important thing is this equal sign. It changes our drawing, and it changes whether they're open or closed. Our last one is kind of a special case. It is where x is somewhere between negative infinity and infinity. So that is all real numbers. To draw that, you just have to draw a line and just shade everything in. It is the entire number line. Now, an example of this would just be a true statement involving x. It might be something like x equals x. It's true for all real numbers. 0 equals 0, 1 equals 1, 1.0001 equals 1.001. All right, down below it says write an inequality that corresponds to the given interval. So you just have to ask yourself, am I looking for really small numbers or am I looking for numbers bigger than a specific number? So if I have negative infinity all the way to 9, I'm looking for numbers less than negative 9. So writing an inequality that matches this, well, we're going to note that as parentheses. That's why we just use less than. We're not doing an equal to sign. So we're just going to say x has to be less than negative 9. And that is my inequality. Our next one, we do have a bracket. We have a bracket, and I'm looking for numbers that go to infinity. So I start at 0, and I go to infinity. So I'm looking for numbers that are greater than or equal to. Zero. So that's just x has to be greater than or equal to 0. And although you could write this as 0 is less than or equal to x, I usually do not. I usually put my variable on the left-hand side. It just makes more sense when you're saying it. Because when I say 0 is less than or equal to x, you kind of have to think about a second, and you actually probably reverse it in your head. So we're just going to stick with just putting our x values on our left-hand side. All right, the next thing we're going to talk about, well, if I have unbounded intervals, including infinity, we also have bounded intervals that do not include the symbol infinity or do not include infinity. We have a starting and an end value that do not include 0. So our first one is this a is less than x is less than b, which is just saying x has to be bigger than a and x has to be less than b. Our interval notation will be parentheses because we don't have equal to signs. And we'll have parenthesis a to parenthesis b. Once again, this is open because I'm looking for a number bigger than a, but you can't actually name that number because like we said with 1 to 20, if you have parentheses around it, you can't actually use 1 or 20. We don't actually know what value we start or end with. So this is going to be an open type system, our graph. You just have to show me where a is. You have to show me where b is. Since we're using parentheses, we'll put a parenthesis on a. And b and x is somewhere between those two values. Our next one's the same, except this time it's closed. I actually know what value starts. It starts on a. It ends on b, including a and b. So since it's closed and we're using equal to signs, it's going to look the exact same, except this time we're going to use brackets, square brackets, to show that it actually includes a and includes b. Our last example. Most of the time it's called neither. You're either open, you're closed, or you're neither. Our book uses this term half open, where part of it's open, part of it's closed. Usually we say neither because it leads to this whole discussion, and some mathematicians came up with a word called clopen, that's closed and open at the same time, half open. I usually gear towards it's just neither. Either it's open, it's closed, or it's neither. So I usually say that this is neither. But a drawing of this would just be making sure you find your a and your b value. And making sure you know which one is your square bracket and which one is your rounded bracket. Well, if we notice that it's a is less than or equal to x, that equal to sign goes with the a. So our a will have our bracket, our b will have our parenthesis, and it'll look something like that. Usually speaking, it's either open or it's closed. It's not usually both at the same time. All right, pushing on. Linear inequality is just like a linear equation, like ax plus b equals 0. With one huge change, we are going to change that equal to sign to either a greater than, or equal to, less than, or equal to symbol. And since they are just linear equations, we are going to use the same methods of solving them with one huge exception, and that is the fact, and I have it bolded, I got it big, I got an asterisk by it. It is when we multiply or divide by a negative number, we must reverse the inequality symbol. So whenever we're solving these, you're going to think about whenever you're dealing with negatives, if I'm multiplying or dividing by that negative number, we need to flip the sign, which is exactly what we need to do in this first one, actually. So we're going to go ahead and solve this. We're going to start out the same way I would as if it was just a linear inequality. I would add 9 to both sides, which would give me negative 3x is less than 9. But now we are going to divide by a negative number. And anytime we divide or multiply by a negative number, something should shoot off in our brain. So we are divide by a negative. We need to flip the sign. So instead of x is less than negative 3, we're going to have x is, we flip the sign, so we're going to be greater than negative 3. Now it does also say to write your solution in interval notation. So we do have to use interval notation. I'm looking for all those values that are bigger than negative 3. So that must mean we go from negative 3 all the way to infinity, because those are all the numbers bigger than negative 3. There's no equal to sign, so we're going to put parentheses around both. So this is our interval notation. Make sure you read the directions on the exam. It might ask for graphs, it might ask for interval notation, or it might just ask for your solution. So it says solve and write the solution set in interval notation, so we did both. Our next one, we're going to treat it as just a normal linear equation. We are just going to get rid of the fractions by multiplying both sides by 4. 4 times 1/2 is 2x minus 12. I don't need to flip the sign because I'm multiplying by a positive, so that does not include flipping the sign. Then we have 1x plus 8. Let's go ahead and subtract x from both sides. I'm going to have x minus 12. It's bigger than or equal to 8. Add 12 to both sides. I guess I can show that too. And in the end, we're going to have x is bigger than or equal to 20. Not full points because I did not write it in interval notation yet. So writing that in interval notation, I'm looking for really big numbers, anything that's bigger than or equal to 20. So we are once again going from 20 and we are going to infinity. Infinity always has a parenthesis around it. Our 20 is actually going to have a square bracket because it is an equal to sign. And we have 20 to infinity. The biggest mistake I find people do on these is they write this in the wrong order. They'll put negative infinity to 20 or something like that. Just make sure when you have x is greater than or equal to 20, just really quick, well, this includes 20, 21, 22, 23, 24. Yep, those are all bigger than 20. Just do that mental check. Don't lose points just because you're going through it quickly and you can't do a quick check. All right, so most of the time we do okay on these sections because it really is just solving linear equations. Just got to worry about whether you have to flip it or not. What people really mess up, though, is when we get into compound inequalities. And so please stop me if you don't understand what I'm saying. So compound inequalities are just connecting two inequalities with the words and, or. Well, this already happened. This already happened. If we look back here, all of these sets are actually and statements. They were just buried into it. Now we're going to explicitly talk about them. So we're going to connect two inequalities with the words and or. Now the first one we're going to talk about is intersection. An intersection is just what both sets have in common. In other words, it's our overlap. If you think about an intersection, what we use every single day when we drive, when you get to an intersection, it is just that like square where both roads overlap. You don't count the entire road as the intersection. You just count that overlap as your intersection. So in fact, we use that term correctly when we're talking about driving. An intersection is just that overlap. What is on road A and B? Where is that overlap? So the symbol we use for this is an upside down U that looks like this. That symbol is also the mathematical representation of the word and. So the statement A upside down U, B is read A and B. It is in set A and it's in set B at the same time. What example did I use? I came up with two sets. I just want to use the same ones throughout. So I said we're going to let set A equal just a few numbers. Just 1, 2, 3, and 4. And we're going to let set B just be the numbers 3, 5, 7, and 8. And so if I was doing A and B, that's another A, and B, I'm looking for any numbers that are in both set A and set B at the same time. Well, the only number that's in both sets is this number 3. A also has 1, 2, and 4, but B has 5, 7, and 8. So the only overlap between these two sets is the number 3. So the solution to that one would just be 3. We won't be dealing with sets, we'll be dealing with numbers. But just so you kind of get an idea of what I'm talking about. The other thing we're talking about is union. What belongs in either set? So the symbol we use is just a U. So the statement AUB is read, so upside down stands for and. This right side up one stands for or. I'm in set A, or I'm in set B. So it's no longer just the overlap. It is everything that's in set A, included with everything that's in set B. So if we use those exact same numbers where A equaled the set 1, 2, 3, and 4, and B equaled the set 3, 5, 7, and 8. Ooh, I forgot to put a B there. We have A union B is going to be everything that's in set A. So that would be 1, 2, 3, 4. Or it's in set B. So I'm going to list everything that's in B. Well, we already listed 3, so we just got to tack on 5, 7, 8. So upside down, intersection, is just where they overlap. Right side up is a union. It's our or, so you're going to list everything that's in set A. And you're also going to list everything that's in set B and push it all together. So that's why they call this usually union. You're pushing those two things together. You're unioning these two things. You're listing everything. Intersection, just their overlap. All right, let's do some examples. So this is more examples with numbers. So now we have A equals 1, 5, so all the numbers between 1 and 5, not including 1 or 5. B is all the numbers between 3 and 7, including 3, but not including 7. And C is all the numbers between, from 6 to infinity, not including 6. So the first one we're doing is A union B. Our union is or. In other words, we're pushing the two sets together. We're listing everything that's in A, and we're going to include that with everything that's in B. So let's list our set A on the number line. A is all the values from 1 to 5, not including 1 or 5. So on a number line, it looks something like this. I have parentheses on 1 and 5. Our set B would be 3 to 7 with a bracket around 3 and a parenthesis around 7. Now A union B, we are going to list everything that's in A. Then we're going to combine that with everything that's in B. So we're going to take everything that's A and write it down here. Then we're going to take everything in B and write it down there. Well, that will be all the numbers. A starts at 1. It goes all the way to 4. But B, or all the way to 5. B continues all the way to 7. So when you combine both of these sets together, you're going to have all the numbers between 1 and 7. Our next one is our intersection. In other words, our and. These are all the numbers that have to be in A and in B in the same time. So once again, our graph of A would look like 1 all the way to 5. Shade that stuff in. Our B value would be all the way from 3 all the way to 7. We are not pushing these two things together. In fact, we're just looking for that overlap. What numbers do these have in common? So if you look at this little section here, that's going to match this little section here. So that is, in fact, our overlap. Here's where it gets a little tricky. Well, 3 is in B, and the number 3 is in A. So we're starting at 3, and 3 is included in both sets. So we're going to put a bracket around 3. Here's where it gets a little tricky. So this goes to 5, but this also goes to 5. But 5 is not included in set A, so it's not part of the overlap. So you have to take this parenthesis. So it's going to be a bracket from 3 to a parenthesis there. That is our complete overlap. Our last one is A intersects C. So where do they overlap? A, once again, is 1 to 5. But C, we haven't used C yet. C was 6 to infinity, not including 6. So now we're looking at where do these two things intersect? Can anyone tell me where these two things intersect? Liam?
No.
They don't. There's no overlap. So if I ask this on a test, you just put like a circle or just can't do it. Not possible. There is no intersection. Basically, two streets running parallel to each other, they never intersect. Your big thing is studying to know whether it's an intersection or a union. Typically, if you know how to do it, you can figure it out. It's people flipping them, what they mean. So study them. And I think the easiest way to think about it is U stands for union, and union always means putting two things together, right? Like a wedding is a union of two people. You don't just marry what overlaps, you marry the entire people. It's everyone. Union is pushing two things together. Intersection is slapping them off at where they intersect. All right, we're supposed to solve each of these inequalities. We're also going to go a little further than that. So both of these, all these inequalities have an and or an or statement between them. So these are compound inequalities. You're going to treat compound inequalities as just individual inequalities until they are solved. So I'm just going to look at that 2x minus 3 is greater than 5 to start off with. And I'm going to go ahead and solve it. So that would be adding 3 to both sides. So we'll have 2x is bigger than 8. Divide both sides by 2 and we'll have x has to be bigger than 4. Then I'll focus on the other one. The other one I subtract 4 from both sides to give me negative x is less than or equal to negative 1. I do need to multiply both sides by a negative, but something should go off in your head saying I'm multiplying or dividing by a negative number. I need to flip that sign. And so we're going to have x is bigger than or equal to, not a negative 1, but a positive 1. Now let's put that and in there. And means we're looking for an intersection, an overlap between these two things. So an easy way to find the overlap is to graph everything. Either graph them in your head. A lot of people can do these in your head. I'm going to do them on the paper. So let's graph x is bigger than 4. Well, x is bigger than 4 is going to look something like this. I guess we could have a 3, a 4, a 5. I'm looking for everything bigger than 4, not including 4, so that would be a parenthesis, and it looks something like that. Other thing is it has to be bigger than or equal to 1. X is bigger than or equal to 1. So our graph of that would be, well, we have a 1 with a bracket on it. I guess 2, 3. Let me do something like that. And don't forget, it's an and statement. An and statement is an upside down U, and I'm looking for where these things overlap. Which numbers are in both of these sets at the same time? Well, 1 isn't in both, 2 isn't in both, 3 isn't in both, 4 almost is. 4 just has a parenthesis up here, but everything else after that is in both sets. So our overlap basically will be this section here along with this section here. That's our overlap. So we are just going to have 4 with a parenthesis on it going to infinity because all those numbers are in both sets at the same time. I'm also going to put this in interval notation because I will probably ask that. So this would be 4 to infinity. So if I ask for interval notation, that's how you'd find it. Either actually physically graph them, picture them in your head. I'm not going to make you graph all of them. In fact, this one isn't that hard. This has to be bigger than 4. This has to be bigger than or equal to 1. Where they overlap, just that x is bigger than 4. All right, 2 more to go. This is an OR statement. So it is a union. We're going to solve it just like normal. So we have negative 3x is less than, so I subtracted 4 from both sides. That would be negative 6. I am dividing by a negative, so we're going to flip our sign. And we are going to have x is greater than 2. Let's do the next one. I'm going to start off right off the bat with dividing everything by 3 rather than distributing it. So that's going to give me x minus 2 is less than or equal to negative 2. We add 2 to both sides. We're going to have x is less than or equal to 0. This was connected by an OR statement. OR means union. It can be in either set. So I'm looking for numbers that are bigger than 2 or they're less than or equal to 0. Once again, let's just go ahead and graph it. So I'm looking for x is bigger than 2. That graph might look something like this. Well, if I had 0, 1, 2, we're going to put a parenthesis at 2. That'll be everything bigger than that. Our graph of x needs to be less than or equal to 0. We'll draw a number line. Let's put 0 at the same kind of place. 1, negative 1. We do need a bracket. It's less than or equal to, so we have a bracket, and it'd be going in this direction. Once again, this is an OR statement, so we're actually saying A union B. Push these two things together. So we're taking everything in that first set, so that's 2 is bigger than, so let's go ahead and go 0, 1, 2. Let's do a negative 1, negative 2. Everything that from that first set would be bigger than 2. Everything from the second set would be 0 or less than 0. So that is their union. It's pushing those two things together. In interval notation, that would just be negative infinity. So I start at the smallest value. We work right until we get to 0. So we stop at 0 and we put a bracket, a square bracket, because it is included. And then we're going to put a union symbol. And then we start at the next value, which is 2, but it needs a parenthesis by it. And that goes to infinity. So that is the interval notation of that solution. All right, last one. Last one. This is an AND statement. It is saying negative 4 is less than or equal to 3x minus 1 and 3x minus 1 is less than 5. But rather than breaking this up and putting it into an AND statement, I'm going to solve it as is. All right, we're going to solve it all at once. And we just normally have to get x all by itself on one side. In this case, we're going to get x all by itself in the middle. And the two right and left sides are going to become your numbers. So the first thing I would do is we need to add 1 to get rid of that 1 in there. But since I now have 3 sides of this equation, you have to add it to the very left one and the very right one, which is going to give me a negative 3 is less than or equal to 3x is less than 6. Now we're going to divide everything by 3. Maybe I should write that a different way so it doesn't look like a bar. So I'll divide that by 3, divide that by 3, divide that by 3. And we are going to have negative 1 is less than or equal to x is less than or equal to 2. If you're ever dividing or multiplying by a negative number, you have to flip both sides. All right, so if this happened to be a negative 3x and you divided by a negative 3, you'd flip both sets of inequalities. I like these. These are easier to graph and they're easier to write down because the graph is just x is somewhere between negative 1 and 2. Well, that's cool. I just have to draw one graph. And that is basically I have to go from negative 1. So let's go negative 2, negative 1, 0, 1, 2. My 1 looks like it has a bracket on it because it does have an equal sign. My 2 has a parenthesis. And x is somewhere between there. And writing the interval notation is a lot easier. It's just negative 1 to 2. These should be the easiest to see. Sometimes the overlap looks hard when you have an and or an or statement behind it. All right, once again, maybe this is kind of boring because you've seen it all before, but it is a lot of material. That's a lot of material all at once. That was several sections out of Algebra 1, several sections out of Algebra 2. So there's a whole bunch of information. Please do the homework and work hard on it. But were there any questions on anything that I did today where you're just like, I don't remember that? That doesn't make any sense. All right, then what questions did we have on the homework that was due today? Like I said, I'm going to check it tomorrow. We just have too many people absent today for me to check it today. Jack. So 111 was probably the hardest one. Probably not one I'd put in the test unless I'd put it as an extra credit. What makes it so hard is because there's nothing super concrete about it. Your number one thing is to come up with your equation. Your circle equation is x minus h squared plus y minus k squared equals r squared. And your whole goal is to replace all of those variables with a number or another variable. Well, the first thing we can do is we can look at this little block here. And as I put here, I just put this as an xy plane where this is my origin. So if that's my origin, I'm actually going back -5, and I'm going up 1. So this point right here is really just the point -5, 1. Well, that means my x value is -5, and my y value is 1 in that circle equation. So I replace this x with this -5, which you can see, let's highlight it here. And I replaced, not there. And I replaced that y value with that 1. So I replaced it right there. Now I still have an h and a k and an r. You can't solve for 3 variables if I have one equation. So we have to do something with this h and k. And what I said, if I go back to the fact that we have an origin here, and I'm trying to find this point that's right in the center, well, that means I would go left -r units, and I would go up a +r units. So that's why I came up with this center being -r, r. Rather than having h and k here, I have r and r. So this is actually my h value, and this is my k value. Although not actual numbers, when you plug that into the equation where your h equals -r and your k value equals r, all we have is -5r squared plus 1 minus r squared equals r squared, and that is completely solvable. And it comes down to 2 answers. One is about 6.16. That can't work. It can't work because we know our radius has to be less than 5. Because if it was bigger than 5, our circle would have to be a lot bigger. So we get rid of that one, and we're left with 6 minus square root of 10. I would put that in a decimal. I don't know why I didn't, but I would put that as a decimal answer. Does that make sense? Yeah. Okay. Other questions? This is probably the toughest one on there. Questions going once? Twice? All right. What was that?
You do 104.
Oh, yeah. Whew, just under the wire. 104?
Yeah.
Did we have a 104? Did we have a 104? Oh, yeah, it's just, yeah. 104 is just a skydiver steps out of an airplane at 5,000 feet. We're supposed to use that formula. So we need to come up with 2 bits of information. We need to know the initial velocity and our initial starting height. Well, we know our initial starting height is 5,000 feet. The only thing we really have to think about is what's our initial velocity. And when you jump out of a plane, you're just stepping out of the plane. So your initial velocity is 0. You have no downward momentum until gravity takes a hold of you. Remember, our initial velocity is kind of like you're getting shot out of a cannon. How fast are you being pushed in that direction? I'm not being pushed down. I'm just taking a step off, and so my initial velocity is 0. So here's a picture of all the work. That's why I put here that there was no initial speed. So we put a 0 in for our velocity. And we're looking when I'm 4,000 feet, so we put a 4,000 in for that S.
Yeah, now that you explained it, that makes sense.
Good. Yeah, it's a bit confusing because you got to think about your own initial velocity.
Yeah,
initial velocity, if nothing's acting on you, then it has to be 0. Like a ball, you're hitting it with a racket. You're going against gravity. So generally we have initial velocity going up, but generally if we're dropping something, our initial velocity is 0. Like if I'm like dropping a toy in one of those arm grabs, it's 0 because I'm just letting go of it.